So this is my first attempt trying to make a gravitation YouTube video. So here we go. So we begin with the geocentric model, and you can see that the Earth is in the center, and the Sun and all the planets are going around the Earth. It's easy to draw to this conclusion, as many people would look up at the night sky and they would see it move across the night sky. This person right here, his name is Copernicus, decided that this is incorrect. What he noticed was something called retrograde motion. He would notice that the stars would seem to zigzag across the night sky. For example, this is Mercury. Oh, sorry, this is the Earth, and comparing it to Mars. And you can see that the Earth will overtake Mars, and the result will be this zigzag-like pattern in the night sky. This would show some time-lapse photography of the same kind of deal. If we take a step back then, you can see how the heliocentric model was then decided upon. The Sun in the center and the Earth and all the planets revolving around the Sun. At this point in time, Tycho Brahe steps in. Tycho Brahe was known as being the best naked eye astronomer the world's ever seen. He invented many of his own equipment, and he would spend a lot of time looking out this little hole right here in the wall collecting data. With this data, he was able then to try to prove his own theory, which was some combination of the geocentric and the heliocentric model. Here we can see that the Sun is orbiting the Earth, but notice that all the planets are orbiting the Sun. This is totally incorrect, but this was kind of what he was trying to prove with all his data. So he hired a mathematician whose name was Kepler, and what Kepler was out to do was prove the heliocentric model, but Tycho didn't know this. So Tycho had an early death, and during his death, Kepler took all his information and was able to come up with his laws of planetary motion. There are three components to Kepler's laws of planetary motion. One, elliptical orbits. So you can see the center object or larger masses in the center, and the other objects go around the outside in an elliptical pattern. The closer you are to the center, the faster you move, which is the second component. When we're further away, we have a slower velocity. And lastly, you have equal areas of the ellipse in equal time periods. So these three things are done here in my horrible picture. Here's another version of the same thing. Newton comes on the scene in number 3, and what Newton's able to do through his thought experiments is come up with an idea that both the apple and the moon are falling toward the Earth. This is a huge leap of logic. Newton realized that if you launched an object horizontally with enough velocity, eventually that object will stop falling when it hits the Earth, but just fall continually, and he called this falling orbit. Here's some examples of the relationship he came up with. What Newton did is he said that distance is inversely squared when you're calculating the force of gravity. So for example, if we double the distance, you get a quarter of the force. If you half the distance, you get 4 times the force. You can also vary things like mass and different things like this, and this will help you understand the relationship. Cavendish comes on the scene, and what Cavendish does is he uses a torsion balance. So the torsion balance calculates the amount of force between any two masses and the distance between them. He came up with the ratio of 6.67 times 10 to the negative 11. This was done many, many times, and this number goes out even further now, and you can find this in your calculator under the built-in constants, or you can just memorize the number as it's shown in the chart. Here's a video if you want to watch it on the torsion balance. Here's another picture of Cavendish doing his thing. So that completes Newtonian physics, and I'll pick up modern physics in the next video.